Hi everyone! In this video, we will show how to run a univariate multinomial Probit model using the graphical user interface and the dataset provided in the GitHub repository. In this example, we use simulated data to illustrate how the model works. First, go to the Univariate section and click on Multinomial Probit. Then click on Browse and select the dataset from the Data Sim folder named 14sim.multprobmodel.csv. Once it loads, you will see a preview of the data and all the variables included. Next, set the number of MCMC iterations, as well as the burn-in size and the thinning parameter. After that, go to the formula builder, where you can specify the dependent variable, along with the alternative specific and non-alternative specific variables. Before clicking on Build Formula, define the base alternative, typically the last category. For example, with 3 alternatives, the base is alternative 3. You should also specify the number of alternatives and the number of variables in each category. You can modify the prior mean and the variance-covariance matrix, which is usually assigned an inverse Wishart prior with specified degrees of freedom. Once everything is defined, click Build Formula to generate the equation, and then click Go to run the estimation. You can confirm the model is running when the message "Working on R" appears in the bottom right corner. This process may take a few minutes. The app will generate posterior summaries of the model's parameters. Since we are using simulated data, we can compare the estimated coefficients with the true values used in the data generating process, available in the file 14sim multinomial probit.dar. This output summarizes the posterior distributions, including central tendencies, uncertainty, and convergence diagnostics, allowing for inference in a fully probabilistic framework. In multinomial Probit models, the variance-covariance matrix must satisfy identification restrictions. In particular, one diagonal element is normalized to 1, which is why it remains fixed in the results. Finally, you can download the posterior chains as a CSV file and the graphs as PDF or .eps files. I hope this video was helpful. Thanks for watching!